Okay. So now I am requesting Dhamija ma'am to kindly
Yeah.
start the session. Thank you.
Mm. Thank you, Rohit. Good afternoon to everyone. Welcome to this next serial, next talk of the in the webinar series we are holding as a part of the Azadi Ka Amrit Mahotsav. Every time I tell you that this is a celebration for which we are commemorating 75 years of our independence and our glorious history of our people, culture, and our achievements. This Mahotsav is dedicated to the people of India who have been instrumental in bringing India to this level and also to contribute towards India so that we can move forward as a global economic power. So this is a campaign where everyone is participating. We have a lot of activities planned all over the country, and in Skill Council, we have planned to organize 75 webinars on different sectors of environment, renewable energy, sustainable development, waste, and water management. And of course, the list just goes on and goes on. So we have been having talks, we have been having, experienced and learned speakers who have been interacting with the participants, who have been interacting with all of us, and we have learned a lot in this journey. And we have completed more than 70 seminars. I think the precise number will be shared by Mr. PB Singh in various sectors. And today, in our journey towards zero emission targets, which we are, we all our targets, all our activities are all focused on achieving this goal. We have a very important sector, the EV sector, the electric vehicle sector. Mobility or transport is one area which is producing maximum emissions. In a study for Delhi also, when I was doing the climate change agenda for Delhi, the focus was that the transport sector is the one which is, contributing the maximum to pollutants. So there is a need for this, for a change in the infrastructure, for a change in the way we move or our mobility, and nothing better than the electric vehicles. So electric vehicles, they don't work on fossil fuels, no gasoline, no emissions, and of course, very little noise. For the last 1 week, I also have been using the services of Blue Smart, which is a company which is using electric vehicles, and I feel very comfortable and very convenient and happy because every ride I get a message that you have saved this much of carbon dioxide, carbon monoxide, carbon dioxide emissions to the environment. So this is a change which we have to bring about in our lifestyles, in our mobility, means of mobility. And to say that electric vehicles have been there since long. The MNRE, the ministry was promoting the battery operated vehicles, which were being manufactured by BHL, and these were being done for limited, areas because the cost was high, the mileage was less, and of course the charging infrastructure was poor. So there has been a focus of the government of India to promote electric vehicles. I remember launching the REVA when I was in the Delhi government. That was also one personal transport which was there. But somehow these efforts could not get that push which it was required. Now we have a bigger push, a bigger focus of the government of India for transiting to electric mobility. So here we have FAME 1, now we have FAME 2. I think all of you must be knowing the subsidies which are being given for the batteries which are to be used in electric vehicles. Then I was reading that we have even for manufacturing sector, we have a lot of facilities or a lot of, a roadmap which has been made by the government of India, the Department of Heavy Industry. And the biggest point which are what I want to focus is the charging. There is a separate guideline. I think Neha will also tell us more about this. The guidelines have been issued for the charging stations. They have declared that they will be setting up more than 3,000 charging stations all over 62 cities in the country. And I think this will give a big boost. This was the main point, how to charge, where to charge. NDPL had suggested that time that we can put up charging stations at all the metro stations, but somehow that never came through. And if we have solar charging, if we have solar and electricity, then the well to wheels emissions are also not there. So we don't pollute from the well and we don't pollute from the wheel. So that will be one the best. And here in Skill Council, I can say we also have been focusing on electric vehicles, and we have done trainings, we have developed job roles, 2 job roles, and we have done almost 500 people we have trained for solar plus grid-based charging of electric vehicles. So here, I'm happy to share we have 123 women candidates who had participated in these trainings. So this was a big, achievement for the council also, that we are also moving side by side, hand in hand with the government. Batteries also something which are getting more focus. Charging infrastructure, battery manufacturing is something which has to get, there has to be focus. And I think there's a phased program now, phased roadmap on how we have to move for manufacturing also. So I think I've talked a lot, because this was a subject I feel which does need a focus. And I would again, say that today we will be learning a lot from Neha. She is she's working with the government of Jaipur Vidyut Nigam Limited as an electrical engineer. And I welcome you and I thank you, Neha, that you have really, you know, you have accepted our invitation for coming and joining with us and giving us the information and also to our participants. Welcome once again. Now I request Mr. P.B. Singh to kindly introduce Neha and about her achievements, accomplishments, and how we gained today. Thank you very much and welcome once again.
Thank you, ma'am, for welcoming the speaker and other participants. Thank you very much. Good afternoon, everyone. I'll welcome you all of the 72 series of the webinar. Skill Council for Green Job is organizing a series webinar to celebrate Azadi Amrit Mahotsav as a part of India's celebration of 75 years of independence. In this series, SCGJ is inviting eminent and learned speakers in different sectors on sustainable development, renewable energy, and waste management, so as to deepen in understanding of recent developments in these sectors. The first in the series was launched on 24th September 2021. Today we have Engineer Neha Sakka, a very experienced learner, distinguished speaker who will be sharing his expertise on and experience on EV charging infrastructure, beginner's guide made easy. I would like to share her brief profile with all of you. Engineer Neha Sakka is an electrical engineer at Jaipur Vidyut Vitran Nigam under Government of Rajasthan, with the aim of saving the only home planet using electric vehicles as the medium. She is working to develop India as a skilled workforce hub in the EV sector in global market. She is achieving the same with her free education program, Trust EV Awareness Oath, empowering youth and women, which is sowing the seed of EVs in the heart of youth. Engineer Neha holds the firm belief that in order to grow, it is the EV industry that direly requires the unique talent of our youth, etc. That with unique talents of our youth, the EV industry can boom to the extreme. Our youth's brain simply need to be trained in this field. Engineer Neha was honored with the National Excellence Education Award 2022 by the Honorable Minister of Heavy Industries, Sri Mahendranath Pandey, in the National Youth Parliament 2022. Engineer Neha has also represented India at the International Virtual Women Youth Summit. She is also the first female professional engineer of her conservative society. Now I am requesting Engineer Neha Sakka to start the presentation. Over to you, Neha ji.
Thank you so much for such a beautiful introduction and for inviting me on this platform. It is such an honor to be here with you and to share the tiny bit of knowledge that I have in electric vehicle. Am I audible and am I visible?
Yeah,
Thank
Audible.
you.
Please continue.
yeah, please continue.
So today we are going to learn about the electric vehicle charging infrastructure. So I want you to consider that the electric vehicle industry is a really huge industry and we really want to learn everything about it in one go. However, we cannot do that. We cannot eat all the food in one go. We have to
Yes.
eat it step by step, chunks by chunks. So today
Presentation.
we will be
Hello, ma'am. Sorry to interrupt, ma'am, but your presentation is not visible, ma'am.
kindly share the rights to share the presentation. It is at the
Ma'am,
host only, I think.
no, I already give you the rights, ma'am.
So today we are going to talk about the charging infrastructure and that will be our focus. So focusing more on the charging side, the infrastructure side, we would be leaving electric vehicle technology as a transportation medium alone today. So our focus would be the charging infrastructure. The aim is to make you feel more confident than you are feeling at present right now after the end of the webinar in terms of charging technologies and electric vehicle infra. So that is my aim, that you feel confident, you feel more comfortable when you're talking about electric vehicle charging. We will be discussing everything in really simple language, in simple terms. We will not be using a very high-tech kind of terminologies to make you feel that the webinar is having a lot of technical and highly specific knowledge, but it is to make you feel comfortable. It is to make you feel confident about it. So the things will be explained in very simple language so that you feel that these are very easy things. How can this technology be that complicated? It is so easy. So that is my aim to start with. So we are going to discuss these 5 things in today's webinar. I hope that I am able to complete these topics in given time frame because there is a lot to discuss. Let's start with the term, the phrase that we are using today, electric vehicle charging infrastructure. Let's break it down into chunks. Electric vehicle, as already explained, it does not uses the fuel that an ICE vehicle would use. It uses electricity on a general basis as a means of fuel. This electricity is converted to mechanical form via a motor. The motor is controlled through a controller, and regarding all the health issues, regarding all the charging conditions, regarding all the mileage to go, everything is maintained by a system called battery management system. So it is something that is going to tell us about how much charge is remaining, how much more can we drive, how much time will it take to charge the battery. It has got all the information about the battery pack. So these are basic parts of the electric vehicle. And then let's talk about the infra. We are driving our vehicle, our battery is full, and we have driven it throughout the day or a couple of days. And now our battery has drained. Now we need to refuel it, re-energize it. We need electricity for that. To have that electricity made available at our vehicle's battery, we need a whole infrastructure for that. That includes from electricity generation to carrying of that electricity to our battery. Everything in between is the infra. For example, the generating station, then we have the electricity delivery guys, that is transmission and the distribution companies. And then we have the sockets at our home to which we connect our charger, just like for a laptop charger or mobile charger. So that from the beginning to the end till it gets to our battery is the infrastructure. Now let's focus on our term charging. This is our focus for now, so please keep focusing on this term. Charging. Do we have day-to-day life charging? Do we charge anything in our daily life? I'm looking at the chat, kindly answer. Do we happen to charge anything or something in our day-to-day life? I'm looking at the chat. Yes. What do we charge? Can you give me some example? Mobile, pretty much the thing that you're using for now, seeing this webinar. mobiles, laptops, smartwatch, smartphones. We have smart bands. We have mobile fans now these days. We have mobile lights. So many things are there. Anything that has mobile electricity, electricity that can be stored and moved from one place to another, use battery in it. So talking about the types of electricity, what kind of power do we get at our sockets? The sockets that we have on wall, the type of electricity that is being delivered to us by discom, the distribution companies. What kind of power do we have? AC power, perfect. And what kind of power is exactly being stored in the mobile phone or in the laptop, in smartphones, the smartwatches, bands? DC power, of course, perfect. So where is this magic basically taking place? We have AC, then we are getting DC, boom, how? How do we get that? There must be something that is converting things. Converter. Or what do we call it in day-to-day life? Converter, rectifier, we don't use this term at a mobile shop, right? Bhaiya ek rectifier de dena. We don't use capacitor for that. Rectified, yes, but what is it? Charger, exactly, charger or adapter. We use a charger to convert that AC into DC. Now this charger makes sure that two things are happening for perfect. One is that the mobile is getting a particular regulated supply. It is not getting higher voltage or overcurrent. It is not suffering from higher temperature and everything. It is maintaining, regulating the supply that is being given to the mobile or the battery. Second thing that it is doing is it is making sure that the AC is completely converted into DC and there are no ripples or there are no distortion in the supply. So these are the two things. One is the rectification and another one is regulation of the power supply. So we use the term charging for this. Yeah, we use the term charging. I'm charging my laptop, I'm charging my phone, I'm charging my smartwatch, I'm charging my Bluetooth earphone. Okay, so that is the one term that we will keep in mind. I'm simply charging. Another question that I have for you is that when this conversion is taking place, that is the supply that is coming out from the outlet and that is being converted into DC to feed the battery of our phone, where is this conversion taking place? Is it inside the mobile phone or is it outside the mobile phone? Where is the conversion taking place? I'm looking at the chat. Outside the mobile phone, right? And we use the term that is charging for it. We are charging our mobile phone. Have you ever heard that my mobile phone is undergoing DC charging or my mobile phone is AC charging? Have you ever heard these terms associated with mobile charging or laptop charging or charging our Bluetooth earphones or anything like that? Have you ever heard these terms associated with our daily life charging? Is my speed okay? Am I speaking too fast? Are we going okay? Okay, so do we associate AC charging or DC charging with our mobile phone? We don't, right? We do not say I'm AC charging my phone, I'm DC charging my phone. We never use that. We generally say that I'm charging, simple, right? But these terms are now going to become part and parcel of our life because now we have electric vehicles, and electric vehicles do not simply undergo charging. They either go DC charging or either undergo AC charging. So this is now what we are going to understand clearly and simplest form. So just like our mobile phone, we have an adapter, then we have a socket in which we plug in the adapter, then we have a cable that connects the adapter to our mobile phone, and then we feed the battery. The conversion takes place and we feed the battery. Similarly, here also, we have a charger that is a DC charger. We connect it to the input supply at the socket on the wall. We get the connector gun connected to one end at the charger and another end in the vehicle. The supply is being converted into a DC from AC outside the vehicle, and we are simply feeding it to the battery, just like our mobile phone. Another case in terms of electric vehicle in particular, this is what we not see in our laptop or mobile phone, is that we simply feed in the AC supply to the vehicle itself. We are not converting it. We are using the socket. We are taking a supply equipment there to maintain the supply, that we are not going over voltage, over current, or over temperature, all the maintenance issues. So we are getting that supply. It's AC. Make sure to know that it's AC so now, till now. So we take that AC supply and we feed that into the vehicle. But now here's the catch. We need to feed the battery with DC power, not with the AC power. So we need someone to convert it for battery. So we place something called onboard charger inside the vehicle to convert it for us so that our battery can eat the food. Now here, AC supply is given to the vehicle. The conversion is taking place inside the vehicle, and then the DC supply is given to the battery. In this case, there are two terms that defines these processes. They are different, and hence the terminologies. DC charging is when the supply is converted outside the vehicle and the battery is directly spoon-fed DC supply. The onboard charger is not used in this case. However, in case of AC charging, where we have AC supply available, we use onboard charger to convert it and then feed it to the battery. That is the major difference here. So we have two types of charging here, AC charging and DC charging. Now make a note here, when we are talking about DC charging, our charger is doing two things. It is making sure that the supply is regulated. We are not crossing the voltage or current or temperature, or we are not having above or lower frequencies. Everything at the AC condition is maintained by the charging system. Then again, it is converted into the DC form, and it makes sure that the DC power is also regulated. Whereas in terms of AC charging, what we have is called supply equipment, electric vehicle supply equipment. It makes sure that the AC supply that is being fed to onboard charger in order to feed the battery is adequate. It is not crossing the voltage, it is not crossing the current, it is not crossing or getting lower frequencies. It is simply regulating the supply. So it is supply equipment. It is not converting the power. So this is what we have discussed. How does AC charging work? We have a whole infrastructure, whole grid to bring power at our home or at any place where electricity is available. We install EVSE, electric vehicle supply equipment, on the wall or on the pedestal, whatever is available to us. From there, we attach connector gun and plug it into our vehicle, and it simply starts charging. Now, this EVSE makes sure that the power is regulated, as we have already discussed. It also makes sure that there are no faults. If there are any faults, it will indicate it to us, and it will stop the charging. For example, if there is earthing fault, it will also check if the connector gun is connected properly. If it is loosely connected, it will not start the flow of current. So it will tell you how much units we have consumed. It will also tell us how much time is remaining to get the battery completely charged. We don't have to again and again go inside the vehicle and check it. We can see it on the screen of EVSE. Now, these are the normal features that we would use for an EVSE that is installed at our home, right, for private charging. But when we are using EVSE for commercial charging, where we need to earn money and we need to take money and payments and everything, there are more features available. For example, if I'm booking an EVSE, the EVSE should be booked by me. So it has that feature. If I have booked an EVSE, I need to authenticate it. So it will provide me a way to authenticate. After I have authenticated myself through OTP, scan code, or any given link, whatever the means are, I can start my charging. After that, I have charged. I need to make payment. So it will also provide me the payment gateway. It could be through GPay, it could be through PhonePay, Paytm, or through net banking, any kind of payment gateway. So it is acting as an interface between me and the charging management system. We will learn that soon. So this EVSE knows everything about my charging process. कितना charge हुआ है, कितना बचा है, कितना time और लगेगा, सब कुछ ठीक है क्या? It's always communicating to me every tiny bit of information that is going throughout in real time. So it's sort of like a brain of the charging process. It knows everything about it. Apart from that, there are two kinds of EVSE that we can have. For example, if you see on the right-hand side, lower image, wall-mounted. If you install EVSE in parking, that is the best place to install it. We don't have a lot of space on ground to install a complete huge EVSE system. So what we do is we make use of wall and mount it on the wall so that the vehicle can be charged while they are being parked. So that is called wall-mounted. Apart from that, if you are going to parks, if you are going to open area parking, or any place where there is parking available and there's no wall, but there's a space. So we can utilize some space and install pedestal mounted electric vehicle charging station to charge the vehicle. So these are the two kinds. When we talk about DC charging, here the charging conversion is being done outside the vehicle. So all that is required to be done is carry that power inside the battery. Now here we use a high power conversion. So the cable are particularly manufactured to carry high power. There is no use of onboard charger in this case. And also there are certain kinds of connector gun that particularly is used for DC. For example, SHADEMO, charge remove cable. It is particularly used for DC only. CCS, combo type 1, type 2, GB by T are used for both AC and DC. When we talk about AC charging, we would go for type 1 and type 2 connector guns. We will see that soon. Here, you have to note that when we are talking about power rating of both the systems, in DC charging, the power rating speaks that I can convert this much amount of power at any time. For example, 50 kilowatt, I can convert 50 kilojoules of energy per second in that given time frame. So I can feed the battery with the speed of 50 kilojoules. Then we are talking about the power rating of AC charging. It is telling us that I can provide you 22 kilojoules of power of energy per second in AC form. Now that is my maximum limit. I cannot provide more power than that, and that is also in AC form. So that is the output power rating of electric vehicle supply equipment in AC terms. It is not the speed of conversion. It is just the amount of energy that it can deliver in AC form per second. In DC charging, it is actually the speed of conversion. So now I'm looking at the screen. Please answer. What are these terms? Fast and slow charging. How do you tell me that this charger is fast and this charger is slow? How will I judge it? How will we judge it? I'm looking at the screen. How do you call a charger fast or slow? How do you judge it? Based on kilowatt rating. Exactly. Based on kilowatt rating, that is based on power rating. So what exactly will we call that? This is high power rating and this is low power rating. Very nice, very nice. Less than 22 is slow. Perfect. So the main criteria is the power rating. More the power, we call it fast. Lesser the power, we call it slow. So these are the criteria. Power rating is one of the criteria. Now let me know. Please answer yes or no for A, yes or no for B, yes or no for C and D. Do we have fast DC charging system? Please write A and then your answer, yes or no. Do we have fast DC charging system? Have you heard this term? No, yes, okay. Any more opinion? Yes. Please write A and yes so that I can understand. Okay, do we have slow AC charging system? Have we all heard this term? Are we familiar with this term? Yes. Are we familiar with fast AC charging system? Are we familiar with this term? Yes. I would want everyone to answer, please. We are not looking for the right answer. We are looking for answers only. Okay. Are we familiar with the slow DC charging system? Are we familiar with this term? No, because DC is always fast. How can it be slow? Okay, so all four of these exist, and how do we demarcate them? How do we do the demarcation? How do we distinguish them? So what we have seen so far, charging system are of two kinds, AC and DC charging system, and both of them have slow and fast charging system. But how do we deal with them? See, there are power rating, as you have mentioned, as you have told me, that we can use power rating as the criteria. So for DC charging system, what we use is 50 kilowatt reference line. If it is converting power at the speed of lesser than 50 kilojoules per second, it is slow. However, if it is doing at the speed of 50 kilowatt or more than that, power conversion is taking place at that speed, it's of fast charger category. In AC charging system, we have Reference lower than that, we have 22 kilowatt. So if the power is regulated, if the power is being provided to us at 22 kilojoules per second or lesser than that, then it's slow charger. Or if you're getting 22 kilowatt or more than that, that is fast charger. Now, see the difference in the terms that I have used: power converted and power regulated. I will be telling you I have done that soon. Okay, let's talk about the power rating that is being specified in the charging infrastructure for electric vehicle, the revised and consulted guidelines and standard by MOP, Ministry of Power, Government of India. They have released this guideline in 2018, and then again, they have revised it in 2023 with some modifications. So here what we can see is that there are two sections. One is fast and another one is slow. So in fast, there are two categories for AC and DC. CCS, minimum 50 kilowatt. That means that it is a DC charging system, and the minimum power rating to be considered in fast is 50 kilowatt. Same goes for SHAdeMO. It's also for DC system. CCS is for both AC and DC. Type 2 is an AC charging system, and minimum requirement to be classified as fast is 22. Now, what we have in slow DC charging. Slow DC charging, ऐसा भी कुछ होता है क्या? Does it exist? It exists in a way that the power rating is lower. The Bharat DC 001 and AC 001 are India's own standards. They have their own standards in which they have specified that what should be the input supply for this charging system, what should be the output supply, how many number of connected guns can be there at a time, or what should be the current level, voltage level, what should be the means of communication. Everything is specified in these standards. Anyone following these standards can develop their own charging system. So 15 kilowatt is lesser than 50 kilowatt. So we have these chargers under slow chargers. Talking about the charging system again, I need you to answer me which one of these are considered to be slow chargers. These are all DC chargers. These are all DC chargers. I'm going to a charging station. I have three options. I have one with 15 kilowatt, another one with 50 kilowatt, another one with 100 kilowatt. So which would be considered as fast charger? That is my first question. And second is that which will charge my vehicle the fastest? So first question, which one of them is the fast charger? Is my voice okay?
Yes, ma'am.
Is A a fast charger? Yes or no? Is A a fast charger? Can we classify that as a fast charger? Fast DC charger? No, we cannot do that. Can we classify B as a fast charger? C is fast, that is for sure, you are right. But is B a fast charger? Yes, B is also a fast charger. Nice, very nice. So that is the first question. Second question, which one of these, A, B, C, will charge my vehicle with the fastest speed? Which one should I choose? C will do that. Perfect. Now let's talk about AC charging system. Is A a fast charging system? An AC charging system, is A a fast charging system? Yes, no? No. Is B a fast charging system? No. Is C a fast charging system? Yes. So now we have our concepts very much clear. Okay, so I want to get my vehicle charged at the fastest speed. I really want to go out as soon as I can. So which charger should I prefer, A, B, or C? Can I judge this system as I have judged DC system? Which charger should I use? Subject to many variables not listed here. I'll agree to it. That was very much nice. Great observation. Could you list some for me? Okay, the point is very much right. We cannot judge the AC charging system right away without certain points. For example, our onboard charging system. As I've mentioned that the power supply, the power rating of the supply that is mentioned for our supply equipment in terms of AC is for the supply that is made available at the terminal point. It is not the converted power. So here we understand the concept that power supply is sent to the onboard charger, and now onboard charger is going to convert it for us and feed to the battery. So we have to take into account the concept of onboard charger when we are talking about AC charging system. Let's say we have an AC supply equipment, an EVSC that is rated at 3 kilowatt. That means to say that I cannot do anything beyond my limits of 3 kilowatt. I will do all the work per second, but it should be less than 3 kilojoules. So it cannot cross the limit. An onboard charger is rated at 2 kilowatt. What it means to say? It is saying that I can convert all the energy that you sent me per second, but I will not cross 2 kilojoules of energy. I can only convert 2 kilojoules of energy at a time. So I cannot cross more than that. It communicates that to the supply equipment. Know that there is a communication going on. I'm not saying that OBC is directly doing that. We have battery management system also. So I'm telling you that the internal part is communicating it to the external EVIC that do not give me power more than that. We cannot handle it. So that is being conveyed. Having said that, now you tell me what will be the power or the energy converted per second in this case. We have supply equipment rated at 3 kilojoules per second. We have our onboard charger rated at 2 kilojoules per second. Our battery is having 21,600 kilojoules of energy capacity. We need to fill that. So what would be the speed of conversion in this case? 2 kilowatt exactly. So our battery would be filled at the speed of 2 kilojoules per second. And how much time will it take to fill that? The total capacity is 21,600 or 6 units. To shorten that, I'm filling it at the speed of 2 kilojoules per second or 2 kilowatt. So how much time will it take? (21,600 kilojoules divided by 2 kilojoules per second, you will get 108.00 seconds, which you divided again by 60 and then by 60 to convert it into hour, you will get 3 hours exactly. 3 hours it will take. So I saw that, oh my God, my charger is slow, and that's why it is taking more time to convert and to fill my battery. So what I do is I buy a new onboard charger with higher power rating. So I have 3 kilowatt. The same is conveyed, communicated to the supply equipment. Now what will happen? How much time will it take now? What now? Now the power is being converted at the speed of 3 kilojoules per second. Now it will take 2 hours because we are filling the battery by 3 kilojoules per second. All right, that was perfect. So now I saw that, okay, ये तो बहुत अच्छा idea. This is so great. I'm increasing my onboard charger power rating. So my time is decreasing. Let me buy another onboard charger of 6 kilowatt. I'm doubling the capacity. So my time should also be reduced by half. So it is telling the supply that you can send me 6 kilojoules per second. I'll convert it like anything. So now the capacity has increased to convert it. What will be the speed of conversion now? How much time will it take? Three kilowatt, 2 hours again. Why will not it take 1 hour? Exactly. I agree with Vinodji. Why is it not taking 1 hour? It should be taking 1 hour, isn't it? Can it do that? The point here is that's the catch. Although it can convert 6 kilojoules of energy per second, but it cannot receive it from the supply. Supply is limited. Supply has limited power. It has the rating of 3 kilojoules per second. It cannot give more power. Exactly, that is the correct point. So what we had seen here is that when we are talking about the time required to charge, it is governed by two factors. One is the supply available and another one is the rating of onboard charger. So that is what we have to keep in mind so that no one can fool us, because this is an upcoming industry. A lot of things are going to happen and we have to be aware of what we are buying. Okay. For example, I have a vehicle and the onboard charger is rated at 3.3 kilowatt and I go to a charging station. Now there the servicemen tell me that this is a fast charger, ma'am, come and charge here. It will charge your vehicle so soon that you will not realize it and it is so good. It is just that the price is higher because we are taking lesser time here. So you have to pay more money. So I thought that, okay, it's okay if I have to pay more money, I'm getting my work done faster. So I get my vehicle there. But then I realized it is not speeding up. It is not charging at a higher speed. What's the issue? In this case, what will be my charging speed? The charger, the power supply, the supply equipment is of 22 kilowatt, but my onboard charger is 3.3 kilowatt. What is the issue here? What is the speed of supply? I'm sorry, speed of my charging here. Is my question clear? The case is similar to the former one. Even though there is large amount of power available, but my onboard charger cannot convert it at that speed. My conversion is limited here by onboard charger. So I bought a new car with a higher rated onboard charger. Then I went to another charging station, but there only 7 kilowatt was available. Here in this case, the charging will take place at 7 kilowatt speed. Even though my onboard charger can convert 22 kilowatt, I don't have that much of power available. So both the cases are to be considered. In India, the vehicle that we have as of now, they have in general the rating of onboard charger limited to 3 kilowatt in general. That is the criteria. And we have, talking about very good vehicles, we have 11 or 7 or in general 7, but then we have an excellent vehicle, 11 kilowatts also. The top notch onboard charger that is available as of now is Renault Zoe Q car, and that 43 kilowatt of onboard charger is available. So please answer me quickly. We really have so less time and there's so much to discuss. The power supplied from grid, is it AC or DC? AC, perfect. And the power taken by EV battery is AC or DC? Is it AC or DC? Exactly. So now, can the power conversion from AC to DC happen outside the vehicle? Can we do that? Can we convert it outside the vehicle? Yes, no? Yes, by using DC charging method. Now, DC charger, do they use onboard charger? No, they don't use onboard charger. The power is already converted. Okay, if I want to charge my vehicle at the speed of 100 kilowatt, what will I use? AC charging or DC charging? DC charging. Okay, why cannot I use AC charging for that? Why cannot I use that? If I can create a 100 kilowatt DC charger, that is, I can manage that much amount of power for sure. So I can do that in AC as well. Why cannot we create a 100 kilowatt of AC charging? What's the point? What's the major issue here? What is it that you have to improve in this industry? Converter concern. Exactly. Here we have to use the onboard charger, and onboard charger is installed inside the vehicle, and there we have issues of weight, we have issues of space, and then if more conversion is taking place, more work is done per second, more heat will be dissipated. We need to have cooling arrangement for that. So there is a lot of things going on inside the vehicle. That is why we are restricted to power ratings when it comes to onboard power. Rating of onboard charger, we have lesser power rating compared to what can be done outside. Okay, if a supply, I'm talking about AC supply, is of 22 kilowatt, I have an EV of 22 kilowatt, my onboard charger is only of 7 kilowatt. What will be the speed of charging? Will it be going to fast charge, or will it have a different speed? 7 kilowatt. So I think now all the concepts are clear regarding that. So we have certain types of connector guns that are available to us. Please understand that the types of connector guns are the types of charger. For example, if I have a type C kind of charger, and if you have type A kind of charger, do we have type C port cable and type A port cable, or whole manufacturing of the charger is different? Power rating is different, I do agree to that, but I can use type A cable in the adapter of type C. Will it become type A charger then? It will charge at the speed of port A, but will it become type A charger then? What I mean to say here is that we have named the chargers in EVs on the basis of connector guns. So please note that this might be a very frequent confusion. What are connector guns? What are chargers? Someone who is a newbie to the industry, it can cause certain dilemma. So these connector guns are basically the name of the chargers. So that is the deal. And the point to us that we want to discuss today is that these are not standardized all over the world in one way. Just like we have different sockets in every country, we have different charging standards in every country. So we have SAE, Society of Automobile Engineers, J1772. For some reason, they preferred this name. I don't know why. So this is type 1 standard, prevalent in Japan and North America. We have type 2 Mannekes, prevalent in Europe and China. We have Tesla, we have Shadomo, CCS, type 1 and type 2. In India, if you want to use your charging station for commercial purpose, you have to abide by these 6 types of charging stations. Otherwise, if you're using it to charge your own vehicle, private vehicle, you can use any of the standards approved by BIS, of course. So we can use Shadomo, CCS, type 2 only. We can use type 2 AC and Bharat standards. Let's talk about the pins that are being manufactured in these connector guns. There are really a lot of pins, and I will break it into very simple chunks so that you can understand them. We have all seen these plugs. What are the pins in these plugs? Can you tell me? These are 3 pin plug, as you can see. What are these pins for? What is the purpose of the pin in the 3 pin plug? Phase, neutral, and earth. Exactly. We have phase, we have neutral, and we have earth. Phase and neutral is for supply, that is the supply pin, and we have earthing for protective earth. So these are the 2 kinds of pins that we have seen in general. Earlier, not now, but in earlier years before 2015, we could get our batteries out from the phone. And that you would notice that there are 3 terminals. Since it's DC, one is for positive, another one is for negative. There was a 3rd pin also that was for communication. That is for communication. It still exists. It is to tell you that your battery is charged, or if the charger is not connected properly, it is going to give notifications like this charger is not of this particular phone, kindly connect the original charger. So it will keep on communicating to you if there are certain issues. So here we see that there are 2 kinds of pin again. One is the supply pin that was like our phase and neutral supply in terms of AC, and positive and negative in terms of DC. And then we have communication pin. Similarly, in terms of AC and DC charging of our electric vehicle, we have these kinds of pin. First set is for supply, that is phase and neutral. Another one is for protection, that is earth. And third one is for communication. Just in this case, we have 2 kinds of communication pin, that is proximity pilot and control pilot. Proximity pilot is used to make sure that the cable is connected properly to the vehicle. If it is not connected properly, if it is loose, it will tell us to connect it properly. It will communicate that to us through EVSE, through the screen on EVSE. Now, until and unless we connect it properly, it will not give signal to the control pilot. Once it is connected properly, it will give a thumb up. Control pilot will notice that, and it will start flowing the current. Now, control pilot manages the flow of current. It will tell us if the current is flowing, if it is not flowing. If it is not flowing, then the vehicle is charged after the proximity pilot has said yes. If it is flowing, that means the vehicle is still charging. So we have type 1 type of connector gun in which there are 5 pins. Okay, L1 is for light, N is for neutral, that's the supply. Third one is the protective earth, that was for general protection of our earthing. And then we have proximity pilot and a control pilot, simple as that. Now here we have single live wire, that is for in off current, and N is for the neutral go off current. In this, what we have is that it can be used on single phase. It is designed for single phase power. Now, having it on single phase or 3 phase very much depends upon which state you live in. The State Electricity Regulation Commission have their own standards of power rating and voltage supply level. For example, if you're in Rajasthan and your power consumption is less than 5 kilowatt, you can use single phase. But if it is more than 5 kilowatt, you'll go for 3 phase. Whereas in Maharashtra, if your power consumption is lesser than 7 kilowatt, it's single phase. If it is more than 7, you go for 3 phase. So it depends on which state you live in. The power is rated according to the voltage. Here in this case, when we go for 230 volt, 16 ampere current, we have normal power rating of 3.6 kilowatt, which is available on single phase. Now 7.54 kilowatt depends upon which state you are living in. So these are the power rating and these are the pins in it. North and Central America, Korea, and Taiwan is a place where these are more dominant. Mode 1, 2, and 3 are the modes of charging in which we have the information conveyed to the user about the charging process. We have type 2 charger. The difference here between type 1 and type 2 is that we have all the pins similar, but we have more number of live pins. So our power rating is increased here. We have 11 and 22 kilowatt of power available in this form. So this is the reason why when we are talking about fast charging and AC, we will always go for type 2. Slow charging, we will go for type 1. This is predominantly used in North and South America, Europe, South Africa, Arabia, Oceania, Australia. Most important part, it is mentioned in MOP guidelines in India. So we are going to focus on this. Another one is combined charging system. So far, we have seen that we are charging through AC system. In combined charging system, we can go for both AC charging and DC charging. As you can see, the top half of this image resembles to our type 1 kind of connector gun. The lower pins, the additional part, the lower half is for DC charging. So these pins are for DC charging and the upper half is for AC charging. Now this, I want your attention here. When you replace the top half by this type 2 connector gun, the top half by type 2 connector gun, you will get a CCS type 2 kind of combined charging system, and that is mentioned for India. So that is it. But with CCS, we can charge through DC supply also, and we can charge through AC supply also. Type 1 CCS predominant in Japan. Now we have another kind of connector gun or charging system, that is shadow mode. This is particularly only for DC charging system only. It is not for AC charging system. So if you don't have an AC charging system available, a DC charging system available, you cannot charge through AC and shadow mode. So what the manufacturer has to do, they had to install another connector gun socket so that it can be charged through AC also. Now that increases price, that occupies more space. There are a lot of problems. So the solution is combined charging system. There is always a tussle between shadow mode and combined charging system. There's always a tussle between them. In shadow mode, there are 4 slots. One is for positive, another one is for negative, and then there are 2 slots with sections between them. These have the place for control pilot, proximity pilot, and protective earth. In India, there are these kinds of connectors available, and these are predominant. As you can see, CCS type 2 is really dominating in all the manufacturers. Let's absorb. I'll take breath for a while and you absorb what we have learned. All right, moving on to the next. Let's say that we have our charging station, and I'm sitting at the top of my building, the top floor, and on the open parking, I have installed my charging station. There are 10 to 20 chargers there, and there are servicemen who are operating and maintaining those chargers. But I need to know after every hour or after every couple of hours, what is going on? How my chargers are doing, how much electricity have I sold, how much money have I earned, is everything all right? Is it so that one charger is working a lot and another one is not? Should I shut something off? Is there any fault? I need to monitor that because I own it. There are servicemen. I can always call them and ask. They can always come to my office and report it to me, but that's not always possible. I want to have real-time data. I want to monitor them at every second of the day. Is there any possibility that I can get all the data to my top floor from this open parking? Is there any way we can do that? I'm looking at the chat. Is there any way? Wouldn't you want to monitor your charging station because you are the owner and you really want to know what is happening? Wouldn't you want that authority? Yes. So is there any way that I can monitor that from one place, central place? That is done through a charging management system or CMS. Now, we have already discussed that everything that is going during the charging process is known to an EVSE, the charger. So that information is always connected to the charging management system. All the chargers are connected to one place, and that one place knows everything that is going on with every charger that is charging every vehicle. So you know with this CMS that if the charger is free or is it charging. It also monitors that is it working fine or is there any fault so that I can disconnect it. If it is overheated, it has been working from day to night, I can disconnect it from my office itself. I don't have to go there and plug it out. Another thing that it facilitates us with is authentication, as already discussed. EVSE is going to provide us an interface through which we can authenticate as the booker of that particular EVSE. We can make payment, we can have that receipt and everything. So this is done with the help of CMS. CMS gives all these data to the EVSE. Now, it also tells us about the real-time tariff. For example, if you're charging at night or you're charging at day, there is a difference between the tariff. In off-peak hours, you can be charged less. In peak hours, you'll be charged more for sure. It also manages the power. If the chargers are working from day to night continuously without a rest, then it can shut down certain charger. It can also tell us about the revenue earned from particular charger and overall all throughout the day or hourly basis. We have all this real-time data with us. There are many CMS developers in the market. They can develop their own CMS and sell it to you, giving different features to us. So how things work, this CMS has got all the information. So I, using a mobile application that is called e-mobility service provider, I use that mobile application, connect to this CMS, and this CMS is going to tell me about all the chargers that are connected to it, their location, their free time, how much money are they charging, everything is known to CMS. So it will tell me, and everything will be displayed on my app. Now I can use that app and that communication and select one charger and book it. Now that charger is booked, CMS is communicating it to EVSE that you are booked, don't let anyone else use you. So it is going to send a authentication format to EVSE. Now I connect my vehicle to EVSE and it will ask me for authentication. I'll authenticate it using whatever the means are, scan QR or it could be an OTP, anything, whatever it is. So when I do that, the charging will start. Now it will not disconnect until I pay. So I'll say that it's charged. So EVSE will inform CMS. CMS will generate the payment gateway or payment method. EVSE will display it to us. I will pay it to EVSE through EVSE and I'll communicate it to CMS that I have paid. CMS will ask EVSE to let my vehicle go. All these things are being communicated. Now, there are various EVSE manufacturers, there are various CMS developers, there are various mobile app manufacturers. How can they all communicate with each other if they all speak different languages? That is why, to eliminate these problems, what has happened is that an alliance has been formed on de facto method. Major brands have come together and they have formed this alliance called Open Charge Point Alliance, in which all the manufacturers of all the equipments, different equipments, be it on the backend system or the softwares or the hardwares or the equipments, everyone is making sure that they comply to Open Charge Protocol, OCPP, Open Charge Point Protocol, so that any developer or any manufacturer can work with any other developer and manufacturer. It is also in the Bharat AC and DC 001 guideline that they have to be OCPP compliant. Least version is 1.8, and the last time I was updated, the version that was recent was 2.0. So what is essentially required to create an EV charging station? Basically, there are three major requirements. I require charger, of course. I require electricity, of course. Another thing that is, I think, lesser paid attention to, but it is a major deal, that is land. So I require these three things for sure to create my own charging station. Of course, there is requirement of money, manpower. There are a lot of things required, but these are the main things. If I do not have any one of them, I'm not going to have my charging infra. So these are the requisite main thing, the core, the heart of any charging station. So here is an layout of how a charging infra looks like. Here we have first person, that is implementation agency. For example, let's say you want to install establish charging stations all throughout the nation or all throughout your state or district. There are 100 charging stations you want to install, and in that you want to have 10 or 20 chargers. So you need to procure land for them, right? It's your duty. You want to buy land. Now either you can go under buying of land, or you can go under the rental basis. And rental basis, you can either pay fixed amount, or you can go on revenue based sharing model. Now revenue based sharing model is supported in the MOP guideline because this industry is just growing. So for it's like benefit for all. The revenue based sharing is always good. So that you file a service agreement with the land partners. So that's your duty. Another one you have to check, is that land already having an electricity connection? If it is, then good. If it is not, then you have to apply for that electricity connection at power utility. Now, if you have to check if the connection is already existing, is it enough to power all the chargers? If it is, then great. If not, then you have to apply for load extension, again at the power utility. Now, power utility is going to give you the power connection, and then you have to pay them monthly tariff, that is power tariff. So how things are going on? You are acquiring land, you are getting the electricity connection. Now you need to have chargers installed there, right? You have to buy chargers, you have to install them, you have to make sure the land, the ground is perfect, there are no bumps, or there's no dirt or garbage thrown or trash in there. The electricity is running throughout, the tap water is flowing all the time, fans are working perfect, light is working perfect. You have to take care of so much. So what you say is that I don't want to take all this headache. What I need is the final information at the end of the day, that I have earned this much and I have invested this much. That is all. I don't want to do all this mess. I don't want to handle it. So what you do, you hire someone, and that is called charge point operator, who is going to do all of these work for you. And you are the implementation agency implementing the charging station all throughout the district, state, or country. So that is charge point operator, and that another one is implementation agency. Now, we have discussed, okay, so the remaining thing is that I am an EV user. I come to you, I pay you money, I get the charging done. Now you earn from me, you will be paying money to land partners, you will be paying money to electricity utility, and that is your money. So this is how it is done. And regarding EV, how am I going to find your charging station? It is through that network service provider facility that is also mentioned in the MOP guidelines, that anyone who is establishing a charging station needs to have network service provider tie-up. So this was very much overall information I could give you about the infrastructure. In general, I explain every entity in detail. It's a lecture of 3 hours just to explain this picture, but I have given you the overview of it. There are 4 types of charging station in general. One is public charging station, where you go and get your vehicle charged. Anyone can come and get their vehicle charged, pay the amount, and leave. So that is public charging station. Another criteria is captive charging station. And here, what we do is that it is built only for certain particular people. It is not for all. It is captive. It is ours. For example, the company that you are working at install the charging station for your benefit in the basement, in the parking. I cannot come and charge. Even if I pay, I cannot come and charge. It is only built for employee. If you are a student at a college, college has installed charging station for the staff and the students of the college only. I cannot come there and charge. It is for you only. It's captive. It's ours, yours. Okay, so that is captive charging station. And another one that we have is battery charging station, which is not at all used in terms of electric vehicle charging. And that we give our battery, the battery belongs to us, our battery to the charge point operator. They charge it for us, and then we take it back. It doesn't work a lot in electric vehicle in general. And then we have another concept, that is battery swapping station. Being honest, explaining this in 3 lines will not do justice to this topic. It is another topic that I explained in 1 hour lecture, but since I'm just introducing it to you, in battery swapping station, what happens is that there is a charge point operator. He gives you his battery to us. We sign a contract, we deposit certain amount of security money, and we pay that security money. We have a contract, and then every time we have our battery depleted or we have it emptied, what we do is that we give it back to that charge point operator or any outlet of that particular charge point operator, and he gives us the charge battery. Now we will pay certain amount that is required to charge the battery, so on and so forth. Could be 20 rupees or 25. And then we use that battery to run our vehicle. Again, when our battery is at zero, depleted, we will give it to that outlet of that charge point operator and get our battery exchanged. In this case, the battery belongs to the swapping station owner. Now, there are a lot of points in this, like we need a standardization of batteries, about the battery quality, health. There are so many points to be discussed here. But since we have reached the time frame, I cannot go on this topic. Thank you so much for your patient listening. There is a program that I would like to introduce you to. If you can please bear with me for 2 more minutes. It's a free education program on electric vehicle. As you know that electric vehicle education is really important, but it is pretty much costly. So not all the youth, not all the tech students are able to get this education. Even if they do, they pay a high price and the quality is not confirmed. They are not able to judge which course is good for them. Another challenge that EV industry is facing is lack of awareness. So to solve that, I go from place to place, college to college, institution to institution, to teach youth the technical knowledge of electric vehicle. It's a 30-day program free of cost. And I spread awareness to non-technical youth about the electric vehicle. If any of you want to connect to this program to learn, to simply develop your interest in it, to improve this industry, you can contact me on any of these platforms. Thank you so much.
Thank you very much. This was the last part was really amazing. And your commitment to promote electric vehicles is excellent, I should say. And the presentation which you gave, I have a comment that great session. The details you gave about the chargers, the AC, the DC, I am not an electrical engineer. I am more from the biology side, and all this really used to scare me. But the way you explained everything, it was so simple, the onboard charging, these charging stations, and then of course the management of it, the entire concept of managing the entire process. That is something. And I'm very happy to see that an entire process has been developed. The infrastructure doesn't mean that you just set up a charging station. You have got the entire process in place. And I think your awareness campaign and this thing is going to help, because we don't know all this. See, we see some plug points, some points developed in the club. I have seen in other places, public places, I have said how much access I can have if I buy an electric vehicle. I'm not aware. What I was aware that you bring your vehicle to your house, you plug in, and then you charge it. That is what is there. Second, the mileage. I want to ask you one question. How much is the mileage now for per charge? Like, when do you need to recharge? Is it 200 kilometers? Earlier, it was only 100 kilometers. That was the limitation with electric vehicles. Even, these autos, Bajaj Auto, because in the ministry, we had a big program. There also the mileage was a big problem. How much per charge, how much kilometers per charge are you going to cover? So these are one or two questions. After that, I'll take questions from the audience. Yeah, and it was a wonderful session. Wonderful. I have no words. And I've never seen such a detailed thing about the charging infrastructure. Yes, please.
Thank you so much for your appreciation. I am happy that I've achieved my aim. That was to make it simple for everyone to understand. My courses are designed for multiple disciplinary streams. It is not for only electrical and mechanical. Since you belong to non-tech background and you have understood it, I think that I have achieved my aim. Yeah. Thank God for that. The questions that you have put up now, that before that, I would like to mention that under this program, more than...
Yeah, please, I will give you the rights. Yes, please. Just let her answer this question. Then we will come over to you. Yes, please.
More than 1,100 plus youth have been educated, and more than 54 lakh rupees education has already been given for free. So please do join and take advantage. Regarding the question on mileage. See, when we're talking about the cars, now we have mileage of around 400 kilometers. Even if we say that that is an ideal drive cycle condition, we can say that it can drive till 350 kilometers per charge. The question for batteries, battery rating and the range and scooties, as of now, we are having range of 180 kilometers. that is being assured by Ola. Let's take that it is on IBC range, so we will call it like ठीक है हम 180 की जगह 160 किलोमीटर रख लेते हैं. तो डिपेंड करता है, अगर आप 40 किलोमीटर पर डे चला रहे हैं स्कूटी को, तो आपको हर 4 दिन में उसको चार्ज करना पड़ेगा, क्योंकि आप 160 किलोमीटर एक चार्ज में चला सकते हैं. इलेक्ट्रिक रिक्शा का एक अलग क्राइटेरिया होता है, उसमें हमारी स्पीड लो होती है, सो डिपेंडिंग अपॉन कि वो कितना बैटरी का खर्चा बियर कर सकते हैं, दे कैन इंक्रीज द रेंज. अभी हमारे पास वो 110 में 80 किलोमीटर, 110, 140 एंड 160 तक भी आने लगे हैं. सो इट डिपेंड्स कि हम कौन सी व्हीकल की बात कर रहे हैं. अपन सारे व्हीकल को इलेक्ट्रिक व्हीकल करके और जनरलाइज कॉन्सेप्ट पर डिस्कस नहीं कर सकते. हमें इनको
it has to be after every this cabs, they have to charge after every 50 kilometers, or is it that they can go in one charge, they can go
in one charge they can go for 350 kilometers at their best.
Okay.
और अब हमारे पास फास्ट चार्जिंग आ गई है, तो 20 मिनट्स में 80% तक वो वापस चार्ज कर देती है. So we can go for another 200 or 280 kilometers in 20 minutes charging.
Yeah, because here livelihoods are dependent, no? They have to earn.
They have to earn.
If they sit down and wait for charging, then what will they do? You know, that sort of thing. So here it's open for questions. Thank you very much for answering my question. It's open for questions. There's one comment, excellent session. And then of course, Ola goes 130 to 140 when I ride in eco mode. Yeah.
Yes, exactly. Yeah. The assured range is 180 किलोमीटर, एंड डिपेंडिंग कि आपकी रोड्स की कंडीशन कैसी है. अगर आप बहुत ज्यादा घाटी चढ़ रहे हैं, फ्लाईओवर्स बहुत ज्यादा है, तो इट कैन वेरी. हम नॉर्मल बात करें तो इट कैन गो फॉर 160 अगर हम अच्छे से चला रहे हैं, वी आर टेकिंग केयर. एंड एज यू हैव मेंशन कि आप इको मोड पे चलाते हैं, तो इट कैन गो अराउंड 140 किलोमीटर्स. डिपेंड्स कि आपकी रोड्स कैसी है.
So if there are any more questions, please raise your hand. We can, yeah. We had a good audience, and I think it was so simple, well explained that no one has any questions. Yeah. So if there are no questions, there's a question that while using fast, this is from Mr. Vinod Raghav. He says that while using fast chargers, does this impact battery life?
Always. It will always do that.
Okay.
So you have to make a choice. If you are using your battery at a higher C rate, whether it is charging or discharging, it is always going to compromise with its battery life. That is why I'm not going to have a fast charging for my vehicle. I will always put it on charge at night. I'm not going to drive at 2 a.m. or 3 a.m. anywhere. So why go for that? I do agree that it is required when we are doing interstate or inter-district travel. We need it. But that is on occasional basis. We do not need it on regular basis. So कभी-कभी चलता है, you can go for it, but don't make it a habit कि हमें daily ही fast charge करना है. Don't do that. It will compromise with the battery life.
When you go uphill, then the speed reduces. It's difficult. It's more better to go in a hybrid. What do you say in hilly areas? Though we have promoted this, if you see the electric rickshaws and all in all Northeast also we have, everywhere we have promoted because they go very slow. But otherwise, hilly areas, how do you recommend these Ola cabs and all that? Do you think they will be?
Yes, they can work. Just that we need high torque there. We don't need high speed there, right? Even if we are driving a fuel vehicle, we will not be driving it at the speed of 60 kilometers per hour on a hill. Will we do that? We won't be doing that with petrol vehicle also. So we cannot expect the same thing from electric vehicle also. We only drive it at 1/3 of the speed. We drive it at around 30 or 20 kilometers or so if we are going on a hill. So that can be done nicely, decently with electric vehicle also. Again, the range would be lesser in compared कि आप उसको simple flat road पे चला रहे. Otherwise, there is no such problem if the torque is adequate. So we need high torque there.
Okay. There's one question from Mr. Reddy. He says, what kind of issues we are currently facing in EVs? High cost?
I'll agree to it that the initial upfront cost is high. Again, the major problem that we are facing about EV is, you won't believe, it is not the technology itself, it is the awareness. We are not aware. For example, we have, I think, 51 or 40 people here. They know, maybe they know about certain things, but they are also unaware, including me. There are many incentives, there are many programs, there are many subsidies given on electric vehicle or charging stations, on investment of electric vehicle manufacturing. There is so much going on that we are not aware. Government is doing for reducing that upfront cost. It's just that we are majorly unaware. So that is a major problem when you talk about the technology side. Apart from all the myths and all the confusion that comes with unawareness, apart from that, we have challenges in technology side, that is the power rating of onboard charger, and to have good battery life when we are charging at a higher C rate, to manufacture batteries with good raw material that are available in our country itself and that do not cause a lot of pollution, and they are not that much high in cost. So these are a couple of challenges that we are facing. Otherwise, the challenges that is more generally mentioned, that infra is not there, it is not. It was a problem 5 years ago, but now things are changing very rapidly.
Yes, 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 yes. I think the availability of the lithium deposits in J&K, that may have some bearing on the availability of raw material, you know, for this.
Exactly. The reserves have been discovered, and nowadays sodium batteries are getting into the picture.
Yes.
So I would support that, because that would be less or least polluting compared to the lithium.
Yeah, and there's one question about from Mr. Dharampal about the normal life of battery.
Normal life of battery is in general 7 years, 5 to 7 years you can take it. If you're using it very poorly, it can go to 4 years also. But if you're using it goodly, it can go for 6 to 7 years, 5 to 7 years you can go. Ola is giving you the guarantee of 7 years of the battery. They are not giving the warranty. I'm sorry, they are not giving the warranty or a guarantee of the battery life for 7 years. They are saying that it will run for 7 years if you manage it good. However, the guarantee or warranty is for 3 or 5 years along with the kilometers travel. So the life of battery goes around to 6 to 7 years. You can take it. Now, it also depends on how you are using it.
What about the disposal after 7 years? Have
Yes,
standards
exactly.
or practices been developed for disposal? Because with lead acid, we had those problems, you know.
Yes.
Have you?
Now,
yeah.
now you tell me, we have had mobile, I mean to say movable electricity stored since ages. We have been using mobile phones since ages, watches with small cells and that since ages, torch with cells since ages. Why is it that now, it is only now that it is coming into the picture that disposal is a major issue? We have already had these issues of disposal. It is not
No,
a
but
new
you know,
issue.
the
But
limits,
now,
the temperatures rising. No? We have disposal problems because, you know, the
yes,
temperature, the environment is getting deteriorated. That is why these issues have come. So I have
yes,
just wanted to ask you that what are the practices? Have they developed some practices for
yes.
disposing lithium batteries after their life, normal life?
Yes, that is what I'm coming at. So
Yeah.
these issues were there. Now that they are being highlighted, they are becoming major focus and concern is that now we are going to have more of these disposal issues with increasing number of batteries, right? So now what we have is that government is running various campaign to collect all the electronic devices so that they can segregate them properly and they can dispose it of more smartly and with more wisdom. There are many provisions given in various state EV policy that if the battery is used for once, it is not the end of the life. We will use it again with solar and wind energy system, and then we will extract the material, and then we will go on to the final disposal. Now, here is the tricky part. Here we need more and more R&D.
Okay. Okay. So there's one more question. What are the concerns of having standardized batteries like that of LPG cylinders? I don't understand this. Yeah, if you can. Mr. Thomas, can you please explain, Mr. Thomas, if you're there? Mr. Thomas?
Yeah, I'm here.
Sorry,
no, what I meant to say is we're telling about swapping batteries, right?
I got that point. Yeah,
So
nice.
if it is something like an LPG cylinder, we have a standardized thing across the country. You can just pick up and drop. I mean, you can just change it without. So what are the concerns? Is that different vehicle makes have to be consulted, or what exactly are the issues with that?
The first and foremost issue is that if we standardize the battery, first we have to understand that this is only a growing market. We are not at our peak. This is a growing market. So battery manufacturers are also at the nascent stage. Now we provide a restriction on them to produce battery in a particular manner with a particular standard, apart from the important and requisite standards regarding the manufacturing, they might not be that happy with it if we restrict them in that manner. However, when we are talking about the swapping station, it is very much required to standardize the size of the battery, the connector guns that we can connect to it, and to provide the freedom to the user so that it can go to any swapping station or outlet and can have any kind of battery that according to their need and likings. However, the challenge will be faced with the OEMs of the battery, the manufacturers of the battery. Will they be happy with it? Will they accept it? If they accept it, the idea can grow. If
No,
they don't,
why should not they be? Because like we have A3 batteries, A2 AA batteries like that. It's a standardized one. So which makes people use the same product across the country, right? Or even internationally. So the
yes,
moment, so I don't think that they should have a problem, because the moment you go for standardization, then it becomes easier across the, I mean, for global utilization
exactly.
and interchangeability.
Yes, exactly. Just like we have interoperability, you are talking about that, and I agree with it. That is what I'm saying. Or if we are thinking at as a it with a perspective of user, it is really important. It is very helpful to us. It will be. If I'm buying in a vehicle without battery, I can go to any CPU and have any battery. Yeah, it will be. But here we require them to accept it. Things don't go ideally on ground as they go on paper. So if it is de facto on them, if they accept it, then it can be done on a national scale or on our country scale. So it is quite like we need their consent also. If there is anyone in the webinar who belongs to that genre, please do give your opinion. Will you accept that? Why will not you accept that? I have talked to certain people and they said that it takes away our freedom. That was my experience, but I'm not saying all of them are like that, but it was my experience with that particular battery manufacturer. So it may be a problem that they do not accept it. If they do, it is very well for us. We are in need of it. I hope that you're satisfied.
Yeah, yeah. I tell you, I want to thank you from the core of my heart for this such a good presentation and so much of information. And I think today all of us who are present here, we can resolve to move to electric cars. You know, that should
Thank
be
you
the
so much.
resolve and that should be outcome at least. And of course, educate others also that we should go electric. So
Thank you so much.
yeah.
Hello.
Thank you very much. And I would now request, and I'm to thank the participants also for such an interaction with you. And you could solve and tell all the answers. I can tell you this is just great. Okay. So then I'll ask Mr. PB Singh to kindly give a formal vote of thanks. And once again, thank you very much. And I really enjoyed your talk. Yeah.
Thank you.
Thank you, ma'am. Thank you very much for the session. Thank you very much, Engineer Neha, for the very, very informative and excellent presentation. You presented a very good data on the EV and explained very well. Hope participants get this very well. Once again, thank you, Nehaji, for the great presentation. I would like to thank all the participants for his valuable time to the joining the session. Thank you all. Thank you very much.
So
thank you, Nehaji.
yeah, I would just say that I was just reading that by 2030, we should have 50 lakh electric vehicles on the road. So with this sort of an energy and enthusiasm and the way we are moving, I think that will be achievable. You know,
Yeah, it will be.
you must agree. Yeah.
Yes, it's a long dream, but we can always achieve it.
Yeah. Thank you once again. Yeah.
Thank you so
Thank
much
you.
for having me.
Yeah. Good
Thank
day.
you, Nehaji. Thank you.
Thank you.
Yeah.